Hello, geometry students. Welcome to the start of topic 4 on triangle congruence, and we're in lesson 4.1, starting with just congruence. We've talked about congruence, right? We talked about congruent segments, congruent angles. Now we're going to talk about what if two figures are congruent. This is going to involve a lot of our rigid motion talk from topic 3 because rigid motions preserve length and angle measure. They keep your figures congruent. All right, so you heard me throw the word congruent around a lot during topic 3 notes, so you're going to hear it even more today. Okay. Example 1, it says, suppose there is a rigid motion that maps one figure to another. Why does that show that the two figures are congruent? Okay, so let's talk about this picture. Again, we're all about rigid motions and showing two figures are congruent. So in this picture, let's talk about what is the composition of transformations that will map one figure onto the other. So I think we're trying to go from A, B, C, D, E, F to what? It would be A, B, C, so G, H, I, J, K, L, right? So it looks like the first thing we did was we took this figure and reflected it. So this is the first thing. We reflected it over this line, x equals -1. So A prime would be like right there, right? And then we did a translation, right? We slid to the right 2 and down 5 to make A prime come right down here where G is, right? So then A double prime would be G. So it looks like we did a composition. The first thing we did was we did a reflection. So again, remember that goes second, right? We reflected over the line x equals -1. And then we did a translation 2 units right and 5 units down. We did that on A, B, C, D, E, F, and it became G, H, I, J, K, L, right? So there's our composition of transformations, right? That's our rigid motion. So why are the two figures congruent? Well, let's just look at some of the side lengths, right? Because number 1, your rigid motion should preserve length. So let's just look at AB, right? So AB should be the same length as GH, and we can count that. AB is 3 and GH is 3. Let's look at BC. BC should be the same as HI because they're corresponding in the same spot. BC was 1, HI is 1. And we could do this so on and so on. So what this means is that the sizes are the same. They're the same size, right? If their side lengths are the same size. Number 2, the rigid motion should preserve angle measure. Preserve, angle measure. Preserve angle measures. So you can see that there's a lot of right angles here, right? All of these are right angles, right? And you can see that when you transformed it, all of them stayed right angles. So all the angles remain right angles. All angles remain right angles. So what that means is the shape did not change. They are the same shape. And if two figures are the same size and are the same shape, then those two figures are congruent. And that's why rigid motions maintain congruence between your figures. Okay. So concepting, here we go. If two figures have the same size and the same shape, same size, same shape, they are congruent. Right? We can use a rigid motion, which is sometimes called a congruent transformation, to do that because the pre-image and the image are congruent. Again, we use the symbol, the congruent symbol, to say they're congruent. So in this case, this is a reflection across line M. Those two triangles would be congruent. A couple of things to note here. Correspondence. Correspondence is important. Importante for my Spanish-speaking friends. Important. So notice here, A and D correspond. A maps to D. B and E correspond. B maps to E. Sorry. B maps. B maps to E. And C maps to F, right? Straight reflection across. This is important You can't just name the figures however you want to. You have to name them in corresponding order. So keep that in mind as we go through this entire topic, this entire chapter 4. All right, sweet. All right, next. So verify the congruence. Given that triangle XYZ is congruent to triangle ABC, what composition of rigid motions maps triangle XYZ to triangle ABC? So we're going to do this by ourselves first. There are multiple ways to do this, all right? But I'm going to kind of walk you through here what I would do, okay? So the first thing I would do is I would do either a reflection or a rotation. So if I do a reflection, I don't think it's going to be enough to get the triangle XYZ facing the same way so I can just slide. So I actually think I have to rotate this. And it looks like I have to turn it, right, for X to become where A is, I have to turn it twice. Because if I turn it once, X will be on top, right? If I turn it once, 190 degrees, X is on top. If I turn it twice, X will be on the right-hand side. So I believe that I need to do, number one, a rotation of 180 degrees. Rotate 180 degrees. And we're going to do it about the origin, right? So I'm going to rotate, that's a lowercase r, sorry. I'm going to rotate by 180 degrees around the origin. All right, so if you recall what that does, that rule means that all of your x's and y's stay the same in position-wise, but they become opposite of what they are. Okay? So x is at -6, 2. Right? X is at -6, 2. So now x becomes 6, -2. 6, -2. There's x. Y is at -6, 5. So now it becomes 6, -5. I'll do y prime. Z is at -2, 2. Now it becomes 2, -2. And there's z prime. And you can see, maybe I use dotted. Sorry, let's dot it up. And you can see that this figure is now oriented the same way, right? It looks the same as where ABC is. Sorry about this dotted line not being quite right. And now the second thing we'll do is a translation, right? Let's do it in blue here. So to translate now, how do I make x prime become A? Well, it looks like to go to the left 1 and up 1, 2, 3, 4, 5. 1, 2, oh, 1, up 1, 2, 3, 4. So up 4. Do the same thing with Z, right? Move it left 1 and up 1, 2, 3, 4. So all 3 points should go the same distance, same direction, and you'll end up on this figure. So I'm going to go left 1. So that'd be a translation. One sec, sorry. I'm forgetting the notation. So we're going to translate left 1 and up 4. Okay. So now we're going to combine those into one big long composition. So again, we're going to do a composition. The first thing we do is a rotation, so that goes second. So we're going to rotate 180 degrees about the origin. And then we're going to do a translation, left 1, up 4. And that's going to be on triangle XYZ to make it become triangle ABC. And there we go. And there's that composition. Now let's see what they do. Let me click on their little help wrap here. Let me click that. So if we go to Savas, all right, we can investigate with them. All right. So here we go. So what do we have a slider here for? All right. So the slider is going to do the rotation first. So you notice here that would be there's 90 degrees. And there's 180. So notice what they do. They rotated 180 degrees about Z. That's fine. That's fine. I just don't know the rotational rules for that. Okay? It would be more of a figuring out. And then they slide it just 3 to the right to get to A. That's completely fine. Okay? Whatever they want to do, right? There are multiple ways to do these problems. But again, I like to find that use the rules from topic 3. Okay, great. Okay, let's do one more in this video. So let's get out of Savas here. Let's come back to here. Okay. Okay. So example 3 says, given that triangle ABC, EFG, and triangle JKL are all there, which triangles are congruent? So on a coordinate plane, the best way to see if two triangles are congruent is to look at their side lengths, right? These are listed in corresponding order: AB, EF, JK. Let us find the lengths of those three sides and see if only two of them are the same. So A to B. So A to B, right, is right here. I'm going to make my right triangle. If you remember the distance formula, right? The distance formula is the square root of x squared plus y squared. Okay. So AB, we would go 1 to the right and up 4, right? 1 to the right, up 4. There's your right triangle. So it's going to be 1 squared plus 4 squared in the square root. That'd be the square root of 17. That's all we need. EF. Now EF is vertical. We just count 1, 2, 3, 4. That's a length of 4. We don't need the distance formula. And then JK, from J to K. So I'm going to go left 1 and up 1, 2, 3, 4. Same right triangle as AB. 1 squared plus 4 squared. And that's the square root of 17. So you can already tell here that these two are the same. So that means triangle EFG will not be congruent. So it's probably going to be triangle ABC congruent to triangle JKL. So now, as a bonus for us, let's go ahead and see if we can map them onto each other. Okay? So if I look here, it looks like these two triangles are just a reflection of each other. It's a reflection and a translation, but it's not a rotation, is what I'm saying. Because A is down here, J is right there, B is up top, K is up top, C is up top, L is up top. It's just that the B and C are flip-flopped, right? B has to be on the right where K is. So let's reflect it. And let's go ahead and do it on this line right here going in between them. So let's make this our first transformation. This is the line halfway between C and L. It would be the equation x equals -4. So let's do that first. So if I'm going to build my composition of triangle ABC, so it becomes triangle JKL, the first thing I'm going to do is I'm going to do a reflection across the line x equals -4. So I'm just going to count, right? So A is 1, 2, 3, 4, 5 away. So go 1, 2, 3, 4, 5 away. There's A prime. B is 1, 2, 3, 4 away. So go 1, 2, 3, 4. There's B prime. C is 1 away. So there's C prime. So there's like our middleman triangle. But you can see now it's kind of oriented the same way as JKL. So now the question is, which way do we have to go to get to JKL? Well, it looks like from A, I have to go down 1, 2, 3. That's down 3. Not left or right, just down 3. Same thing with C. To get down to L, down 3. That'll get us mapped onto this. So we're going to do a translation. We're not going left or right. We're just going down 3. And that would be the composition that gets us from triangle ABC to JKL. So we should feel confident that they're congruent. So that was a lot, all right? So we have a second video coming up that's a little bit lighter, all right?